Hello, my dear students. I am Dr. R. Murali Prasad, Professor in EC Department, Mlritm. I am going to discuss the subject Analog and Digital Communications. So, you know very well about communications. In a day-to-day life, you are seeing so many communication systems like a radio, TV, radar, satellite. The best example is a mobile phone. So, I'm going to discuss in a detailed manner about what are the fundamental concepts involved in this subject, especially the mathematical treatment required to analyze any communication system is considered. So the analysis. So now, first I'm going to explain about the course objectives, what are the course outcomes, and what is the syllabus. So mainly, you know very well, the total syllabus is divided into 5 units. So the first unit deals with amplitude modulation, second unit deals with frequency modulation or angle modulation. The third unit is about the introduction to digital communications. Nowadays, we are using only digital communications. Most of the analog systems are replaced with digital systems. As on today, most of the communication systems are based on digital only. Now, the unit 4 deals with passband data transmission, and the last unit deals with noise, information, and coding. So all these are very, very important. Especially this subject is very much useful for writing any competitive exams. For EC students, the core subject is communications. So you should have a thorough knowledge about communications. Whenever you are facing any interview, the thorough knowledge about this subject is required. So the first I am talking about the course objectives. You should be in a position to analyze what are the requirements of analog and digital communication systems. So, what is the basic requirement? Requirement is, you know very well, I want to transmit a audio signal, video signal, binary data. Suppose if you take a TV, what you are transmitting is nothing but a audio signal as well as video signal. Suppose if you take a radio, what you are talking is only about the transmission of audio signals. So like that, the requirements will vary from application to application. First, you should be in a position to analyze what are the basic requirements of analog as well as digital communication system. The second one is about the generation and demodulation of various modulation techniques. Really, 80% of the syllabus is about the various modulation techniques. What is modulation and why it is required in a communication system, that I am going to discuss in a very detailed manner. So there are various analog as well as digital modulation techniques. Earlier I mentioned in the syllabus also that amplitude modulation, frequency modulation. Everybody know about a FM radio. FM means frequency modulation. And so next is, you should have a thorough knowledge about the block diagram. So block diagram is nothing but interconnection of so many subsystems. So what is the block diagram of amplitude modulation? What is the block diagram of frequency modulation? Because suppose if you take a radio, what you are processing is nothing but a audio signal. How that audio signal is processed in various stages at the transmitter side as well as at the receiver side. So you should have a thorough knowledge about the function of each and every block. Then what are the various types of baseband data transmission techniques in digital communication. In digital communication only we are using the terminology baseband data transmission and band pass data transmission, and also you should have a thorough knowledge about coding techniques, source coding, channel coding. There are various coding techniques also there. So the concepts about all these are also required to analyze any digital communication system practically. Nowadays, I told that all communication systems are digital only. I told that radar, satellite, and many applications. You are watching a TV. In a TV, you are watching a HD channel. HD means it is nothing but digital transmission. So these are the course objectives. First one about the requirements. Second one is about the various generation and demodulation. At the transmitter side, you are generating a signal. At the receiver side, you are demodulating or detection. And I told that about the function of each and every block in any communication system, and also the concepts about baseband, band pass, and coding techniques. And also about the major part in communication is the analysis of a system with respect to noise. Noise is the major important topic in communication system analysis. Whenever a signal transmitted from one place to another place, it is always affected by noise. I want to know what is the effect of noise on the signal. So effect of noise again depends upon the type of modulation technique. If it is amplitude modulation, what is the effect of noise? If it is a frequency modulation, what is the effect of noise? If it is a digital communication technique, what is the effect of noise? So you should be in a position to analyze the effect of noise on all modulation techniques. These are the major course objectives. Then after successful completion of this subject, what are the course outcomes? That means first thing is about the thorough understanding about amplitude modulation, transmission as well as reception. How a AM signal is transmitted and how it is received. What is the techniques involved at the transmitter side and at the receiver side. In amplitude modulation, mainly we are talking about 4 techniques: amplitude modulation, double sideband modulation, single sideband modulation, and vestigial sideband modulation. So these are the techniques we are going to discuss in analog communications. So we are going to discuss in AM amplitude modulation. Then same way, we should be in a position to analyze frequency modulation. So again, what are the concepts of transmitter and receiver? How to transmit a signal from how to receive the signal. So after successful completion, you should be in a position to analyze and you should be in a position to develop some hardware, how to design the FM transmitter, how to design the FM receiver, and what are the applications of these techniques. So in a day-to-day life, I told that you are seeing so many applications. In various applications, you are using amplitude modulation and frequency modulation. So after completing the course, you should be in a position to understand, and also you should be in a position to implement the hardware practically. And in digital communication, again, we are going to talk about error performance. Error means whenever you transmit, in digital communication, we are transmitting the binary data 1 and 0. When the binary data 1 is transmitted, at the receiver side it may be received as 1 or 0. Whenever the binary data 1 is received as 0, I am saying that there is an error. Similarly, if I transmit 0, it may be received as 0 or it may be received as 1. Whenever the binary data 0 is received as 1, we are saying that there is an error. So how to overcome these problems? So error analysis is required about digital modulation techniques. So that is more important. And what is the model, digital communication model? That means baseband as well as band pass. You should be in a position to analyze immediately once you see any practical. After completing successful completion, you should have a thorough knowledge about what is the model of baseband and what is the model of band pass data transmission. So you should, that is what I'm saying, after successful completion of this course, you should be in a position to analyze a communication system as well as analog as well as digital communication system. What are the blocks? I told that audio signal, how to process, video signal, how to process. So what are the basic building blocks required in analog communication as well as digital communication? So this is what about the course outcomes are considered. Now about the syllabus, what we are going to study in this subject. First thing is that, my dear students, what are the prerequisites to understand this concept? The one is about signals and systems. Second one is probability theory and stochastic processes. So communication deals with the transmission of signal from one point to another point. So you should have a thorough knowledge about signals and systems. Systems will process the signal. So you should have what are the various types of signals, how to process a signal, what are the various transformation techniques like Fourier series, Fourier transform, Laplace transform, jet transform. There are so many transformation techniques they are studying in signals and systems, but mainly what is required is the thorough knowledge about Fourier transforms. So that before starting this subject, we have to revise the subject signals and systems, especially Fourier transforms. What is the other subject that is required to understand the concepts of communication is probability theory and stochastic processes. So why this subject is required is, I told you, always we have to do the noise analysis of any communication system. So noise is always considered as a random signal. Anyhow, I am going to discuss in a very detailed manner what is meant by a random signal. So how to analyze a random signal? That is the major problem. Signals are classified into two types: deterministic signals and random signals. Deterministic signal means like a sinusoidal signal, step signal, ramp signal. All these are called as deterministic signals, and we can represent them mathematically. We can represent mathematically, but it is impossible to represent a random signal mathematically. If we are not in a position to represent it mathematically, how to do the analysis? So that is why the probability concepts are required to analyze the random signal. One thing remember, my dear students, what is the input to the communication system? The input to the any communication system is nothing but signal as well as noise. Signal as well as noise. So one in what we are transmitting, signal is always affected by noise. So now I want to know what is the performance of noise, performance of modulation techniques with respect to noise. So in order to do that analysis, what I am saying is that the noise analysis is very much required. So for that, PTSP knowledge is also required. So two subjects knowledge is required. One is signals and systems. Second one is probability theory and stochastic processes. Okay. Of course, you are studying some basics about mathematics also, like differentiation, integration. Some part of differentiation and integration is also required to understand this subject. But remember, this is the core subject which is required to analyze any communication system. In the next semesters, you are going to study various techniques, various communication subjects also like radar communication, satellite communication, fiber optic communication, wireless communication, mobile communication. But for all those subjects, what is the fundamental subject required is ADC, analog and digital communications. If you are having a thorough knowledge about this subject, then only we will understand very easily all those subjects, satellite, radar, fiber optics, mobile communication, wireless communication, and all those subjects. So this is one of the very, very important subject required for ECE students. Already I told you the total subject is divided into 5 units. See the first one. First unit is about modulation, amplitude modulation. Already I told you amplitude modulation consists of 4 modulation techniques. Amplitude modulation, double sideband modulation, single sideband modulation, and vestigial sideband modulation. Why modulation is required, that I am going to discuss in the next class about. First today only the introduction. So now for all modulation techniques the procedure is same. What is that procedure is? I want to know what is the mathematical representation. How to represent any modulation technique mathematically. By looking at the mathematical equation, you should be in a position to identify the modulation technique. It is very, very important. Very easily you will be in a position, after completing the first unit, you will be in a, by looking at the equation, you will be in a position to tell this is the equation of AM, this is the equation of DSB modulation, equation of SSB modulation. So first step is to write the time domain equation. Then second step is to convert time domain equation into frequency domain equation. To convert time domain to frequency domain, what is required is Fourier transform concepts are required. So using Fourier transform only we can convert time domain to frequency domain. Once you convert to time domain to frequency domain, we can determine what are the frequencies present in the signal. That is more important in communication. I want to know the frequencies present in a signal, that is called as the spectrum. Once you know the spectrum, next step is to determine the bandwidth as well as power. These are the two very, very important parameters. Remember, what are the two important in any interview they will ask, what are the two important parameters of any modulation technique? So remember, one is the bandwidth and second one is the power. So why they are very, very important, gradually we will understand. Now, so I told you time domain equation. Next step is frequency domain equation, spectrum, bandwidth and power. So for all techniques, this is must, whether it is AM, DSB, SSB or VSB. Next step is demodulation. How to generate the signal and how to demodulate the signal, that is more important. At the transmitter side, we are generating the signal. At the receiver side, we are demodulating the signal. So remember, sometimes transmitter and receiver both will be kept at the same place. Remember one thing, my dear students, radio, TV, they are called as only receivers. We are receiving the signal. But mobile phone consists of both transmitter as well as receiver, because whenever we are talking on a mobile phone, we are transmitting as well as receiving. The combination of transmitter and receiver, it is called as the modem. Modem means modulator plus demodulator. Everything you will understand, just only it is only introduction class, nothing to worry. So in the first unit, we are going to discuss about total 4 techniques of AM. One is AM, DSB, SSB and VSB. Already I told you what is required in all these techniques are time domain equation, frequency domain equation, spectrum, bandwidth and power. Mainly are getting the numerical problems on bandwidth and power calculations. I am going to solve sufficient number of problems on bandwidth as well as power. Next is how to generate the signal and how to demodulate the signal. Later in the last unit, we are going to discuss about the noise analysis. So I told you what is the noise performance of AM. noise performance of DSB, noise performance of SSB. So noise analysis is also one of the very, very important topic. One more thing that we are studying is about multiplexing. What is meant by multiplexing? I want to transmit more than one signal through the same communication channel. So how to transmit more than one signal through the same channel? That is called as multiplexing. A simple example of multiplexing is TV. How we are getting a signal to a TV? Suppose if it is a cable TV, we are getting all TV channels through only one cable only. That is called as multiplexing. So in analog communications, we are using frequency division multiplexing, whereas in digital communications, we are using time division multiplexing. Okay. Then about receivers. So the receiver means one of the most widely used receiver is called as super heterodyne receiver. Other one is TRF receiver, tuned radio frequency receiver. Then second unit deals with angle modulation. Frequency modulation and phase modulation together are called as angle modulation techniques. But there is a lot of similarity between frequency modulation and phase modulation that I am going to explain clearly what is the difference between frequency and phase modulation. Again, concepts are same. I want to know what is the time domain equation of FM. Then we are converting time domain to frequency domain. Then what is the spectrum? Spectrum is what are the frequencies present in the signal, that is more important. Nowadays we are talking only about frequencies. All of you are listening to radio. There are so many radio stations in each and every city. How we are identifying that radio station is with respect to frequency. In Hyderabad, 91.1 megahertz, 92.7 megahertz, 93.5 megahertz. We are talking all communication systems, we are talking only about frequencies, but why that concept is required, that also I am going to discuss in a very detailed manner. But remember, frequency modulation is very widely used. One major application is radio, FM radio. All of you are listening to radio. Again, I am repeatedly telling, complete analysis is required, mainly spectrum, bandwidth and power. These are the very, very important topics for the examination. Next is how to generate the signal and how to demodulate the signal. Third unit is about the digital communications. So I already told you, nowadays all analog systems are replacing with digital systems. Why are replacing analog with digital is major problem is with respect to the noise. What is the noise performance of AM? What is the noise performance of FM? So if you see finally I am going to do the comparison, then you will understand why digital communication systems are very widely used when compared with analog communications. I am going to explain what are the advantages, disadvantages, and how to represent a digital signal. Next, in the third unit only, we are going to talking about baseband data transmission. Mainly, in order to analyze any communication, digital communication, you should have a thorough knowledge about sampling theorem. By sampling only, analog signal converted into a digital signal. So if you take any block diagram of digital communication, the first block should be a sampler. So with the help of sampler, quantizer and encoder only, we can convert analog signal into digital signal. But before that, we are pulse modulation techniques are classified into two types: pulse analog communication and pulse digital communication. In pulse analog communication, we are going to talk about three techniques: PAM, PWM and PPM. Pulse amplitude modulation, pulse width modulation and pulse position modulation. Then in pulse digital communication, four methods. One is pulse code modulation, PCM, very widely used in mobile phones and so many other applications. The second one is differential pulse code modulation, DPCM. Third one is delta modulation and fourth one is adaptive delta modulation. So these are the 4 techniques I am going to explain in pulse digital communication. Already told you in pulse analog communication only 3 methods: PAM, PWM and PPM. So this is about baseband data transmission. So in baseband data transmission, what is the outcome? What is the output of a transmitter is nothing but a rectangular pulse. So how the binary data is represented, ones and zeros, how they are represented is in the form of rectangular pulses. So whenever a rectangular pulse is transmitted through a cable, that is called as baseband data transmission. Remember this point. Then what will happen whenever the channel is a free space? In that case, the next unit is about passband data transmission. In passband data transmission, how to transmit a digital signal into free space. That is more important. Nowadays, wireless communication is more popular than wire communications. So then in order to transmit the binary data into free space, you are using this passband data transmission techniques. Fundamentally 3: amplitude shift keying ASK, frequency shift keying PSK, FSK, then phase shift keying PSK. Fundamental techniques are ASK, FSK and PSK. Then again, in order to transmit more than 2 digits, what you are using are MRA techniques like MRA schemes, QAM, QPSK, and already told you error analysis, probability of error. So I told you whenever you transmit binary data 1 and 0, errors will occur. Errors means 1 will be received as 0 or 0 will be received as 1. So whenever you, in that case we are calling it as an error. So that error analysis is also very, very important. With the help of error analysis only, we are going to scheme which modulation scheme is better. But each and every modulation technique having its own advantages and disadvantages. It depends upon the application. Which modulation technique you have to use, it depends upon the application. So I told you, if you want to transmit the binary data through a cable, what you are called as baseband data transmission. In baseband, I told you 2: pulse analog and pulse digital. In pulse analog, 3 methods: PAM, PWM and PPM. But whereas in pulse digital, 4 methods: PCM, DPCM, delta modulation and adaptive delta modulation. But if you want to transmit the binary data into free space, what you are using are the passband data transmission. Fundamental techniques are ASK, FSK and PSK, same as AM, FM and PM. But only the difference is there the input to the modulator is nothing but an analog signal, but here input to the modulator is nothing but binary data. So again, same generation, demodulation, spectrum, bandwidth, power. But in digital communication, instead of power, always you are calculating what is the energy per bit. So that I will explain why you are not calculating the power, why you are calculating the energy. Next is about the last unit deals with noise performance. So what are the various types of noise? The most important one is called as white noise or Gaussian noise. So you should have a thorough knowledge about how to calculate the noise power. So what will happen when the white noise passed through a low pass filter, band pass filter, high pass filter, like that some concepts also required, that all I am going to discuss in a very detailed manner. Mainly the noise performance of analog, and clearly it was given signal to noise ratio or figure of merit calculations. Then is about information theory and coding. So mainly I told that in digital communication you are using these concepts of information theory as well as coding. Coding I told that is divided into 2 parts: source coding as well as channel coding. That where I will explain what is the difference between source coding and channel coding. Mainly channel coding deals with errors. I told you whenever you transmit the binary data 1 and 0, errors will occur. 1 will be received as 0 and 0 received as 1. So how to overcome that problem? In order to overcome that problem, we are going to add the parity bits. That concept is called as channel coding, or it is also called as error correcting codes. two types of error correcting codes, block codes and convolutional codes. That concepts I am going to explain in a very detailed manner. So this is about the total syllabus what we are going to study in this subject. First unit completely deals with amplitude modulation. Second unit completely deals with angle modulation. Angle modulation means it covers both frequency modulation as well as phase modulation. So the third unit deals with baseband data transmission. Fourth unit deals with band pass data transmission. Already told you what is the difference between baseband and band pass. The last unit deals with information theory, coding and noise analysis. So this is the total outline of the syllabus. Now, what are the textbooks you have to go through for this subject? Now, the most important subject textbook is that Simon Atkins, Analog and Digital Communications by Simon Atkins. This covers the entire syllabus and is a very standard textbooks. If you are able to solve the exercise problems, you will become a master in this subject. So that it depends upon you. So that we are going to discuss. I will try to cover maximum number of numerical problems required for the university exam as well as for competitive exams. So there are so many other textbooks also, but it depends mainly the last in reference, the last one, Wayne Tomasi, Electronic Communication Systems. If you go through that subject, you will get a very thorough knowledge about the theoretical concepts. Mathematical concepts are very good in Simon Atkins, but theoretical concepts are very good in the reference books. Third one, Wayne Tomasi, Electronics and Communication Systems. Even reference second book, Dennis Rode and Colin, Electronic Communications, also will get a thorough knowledge. So this is about the course objectives, outcomes, what is the syllabus and what are the textbooks you have to follow. So this is about only the introduction class is considered. So from the next class onwards, I will start the subject is considered. Thank you very much.